So guys, let's continue where we have left off yesterday. Okay, so we were discussing what limit, continuity and differentiability. So now today we'll just discuss some of problems of that chapter. So let me go with one of the type questions. So here in JEE Advanced, there is another type of question that is integer type. What do you mean by integer type? So here they will be giving no options. So you have to find the value of this question. So limit x tends to 0 gx, you have to find the value of this thing. Okay, so where the most important question will be where to start this question. So look at here, this is my gx. This whole thing, this thing is my gx, so I have to start from here. But when you see gx, what do you see basically? You see this thing, whatever is inside this third bracket, right? Now you visualize this thing, and I will show you one thing, and you see this one very carefully. Look at there, differentiation of uv. What was that? Product rule. What was product rule? First take out u, d dx of v, then plus v taken out, d dx of u. So this was product rule which we have studied in class 11 in limits and derivatives, right? Now you see this thing in here. So basically u is what? Look at this one and this one. U is what? U is cosec t. So u, that is cosec t, differentiation of ft. Okay, I'm differentiating ft. Then plus, it looks minus in there. Basically, look at here. If I have to write that one properly, cosec t, d dt of ft, plus ft taken out, d dt of cosec t. This is what it is. Now look at here. Differentiation of ft is what? F dash t. And differentiation of cosec t is what? It's minus cot t cosec t. That's how this plus change into minus. So this whole thing I can replace it with what? I can replace it what? d dt of cosec t into ft. Yes or no? Product rule. From here, this one, I'm just going in the opposite direction. We learned from here to here. Now we are doing from here to here, opposite direction. So JEE Advanced is what? You have to go back to the past. Clear? So that's what it is. I'm going from the answer back to the question. It's like that. Okay? I'm learning the opposite direction. Now listen very carefully. So in here, in place of gx, what I will do is pi by 2x. So everything is important in life. Even your past is important for you to learn from it and apply that thing. Experience. You need to gather experience. So what do you get? In place of this whole thing, what I will write? I will write this thing. So d dt cosec t into ft, right? And that will be what? dt. Understood? Now what we are having? Differentiation, integration, then differentiation means what? Basically, if I go to this dt goes like that. We don't think like that. I'm just giving you an example. So integration is what? Inverse of differentiation, right? So what happens? This integration and differentiation will cancel each other, right? So basically, what we are left with? Only this portion. So we have cosec t f of t, but one thing remains. Integration goes away, but this upper limit and lower limit will remain. So that becomes what? It will be pi by 2 to x. And we know this thing in definite integral. First you put pi by 2 in there. So what do we have? Cosec pi by 2. Then f of pi by 2. And then what we have? Then what do you have? Now put x. So minus of cosec x. Then f of x. Clear? Now I see some values in the question. F of pi by 2 is how much? It's 3. And cosec pi by 2 is how much? Cosec is what? Opposite of sine, right? Sine 90 is 1. So cosec 90 is also 1. So this is 1. This thing is our 1. This thing is our 3. So 1 into 3 is 3. 3 minus, look at here. fx, so this one I will write it as cosec x fx. Am I clear? Understood? Okay, now we'll find the limit. We actually have to find this thing, right? So I have simplified the gx. I have simplified the gx from here. I have made it this one. Now it becomes so small, right? Understood? So let us now solve this thing. Okay, let's start. So we have to solve this thing. So what we have? Limit x tends to 0 gx, this value we have to find out. Now gx is what we have found out? 3 minus, acha, one thing, what is cosec x? Can I say cosec x as 1 by sin x? So I will write this one as fx by sin x. Understood? So that is fx by sin x. So what do we have in here? So what we have? So this becomes, so limit, I will break this one, acha, forget it. Limit x tends to 3, this is 3 only, minus limit x tends to 0 f of x divided by sin x. I hope everyone is clear. F of x divided by sin x, this is what we have. Because it's a minus sign, that's why it's just only 3. I don't want to write limit again. Right, now put the value 0 in here. So if I put 0 in here, it becomes f0. If I put 0 in here, I get sin 0. So do I not get 0 by 0 form? And 0 by 0 form is known as what? Indeterminate form. And whenever I see 0 by 0 form in limits, the first thing that's come into my head is L'Hopital's rule, right? And what was that? Whenever I see 0 by 0, I will differentiate both the numerator and denominator. So it becomes what? 3 minus limit x tends to 0 f dash x. Differentiation of sin x is what? It is cos x. So I get cos x. Now you put 0 and tell me what you get. 3 minus, this becomes what? If I put 0, it becomes f dash 0. This becomes cos 0. Cos 0 is 1. That's why I'm putting there 0, because cos 0 is 1. It's no more undefined. Now what is f dash 0? F dash 0 is also 1. Okay, so what do you get? 3 minus 1. That is 2. Am I clear? So the answer is, okay, different type of problem. So this problem we will solve it by graphically. Okay, so how will we do it? Let's start with this one. It's a new type of problem. I can guarantee that you will find it very, very interesting. So how to start with this question? So the question says the function is R to R, be a function defined by fx is equal to maximum of x comma x cube, the set of all points where fx is not differentiable. Now before doing this thing, we need to learn one key point. There is one key point which we need to learn first. So what is that? We must, I hope everybody knows that all continuous function are not differentiable. All continuous functions are not differentiable, but all differentiable functions are continuous. A very, very important point. Okay, now there is a shortcut of solving this question. So what is the shortcut? The graphically I told you. So let me do the graph, then I will tell you the shortcut. Let's do the graph first. So first thing, there are two functions are there. One function is our x and the other function is x cube. So one function is our y is equal to x and the other function is y is equal to x cube. There are two functions. Let us draw the graph of these two functions. First I will draw y is equal to x graph. Okay, so y is equal to x graph looks like that. It's a straight line passing through the origin. Everybody knows. So this is my y is equal to x graph, right? So I will write here y is equal to x. Here it's x, here it's y. So this is my y is equal to x graph. Now we have y is equal to x cube graph. Okay, now how to draw y is equal to x cube? Look at here very, very clearly. Y is equal to x cube graph, we'll draw it like this. I hope everybody knows what is y is equal to x squared. It is parabola. It looks like this, right? Understood? So y is equal to x cube will be what? It will be like this. This is our y is equal to x cube graph. Do you have a question how to draw this graph? Look at here. It's very easy how to draw. Look, in order to draw lines, what we have learned in class 10, we learned to find out points, right? Yes or no? So in drawing these functions, what I will do is I will start with signs. Tell me, when x is positive, what is the value of y? Is y positive or negative? If x is positive, y is what? It is also positive, because positive cube is what? Positive, right? Now tell me, if x is negative, y is positive or negative? Y is also negative, because minus negative cube is what? It also comes negative, right? So y is also negative. Now tell me which two quadrants in which xy both are positive and xy both are negative. In first quadrant and in first quadrant, x and y both are positive, and in third quadrant, x and y both are negative. That's why the graph of y is equal to x cube will lie on first and third quadrant. Okay, understood? Clear? So that's how I draw it. And this graph will be a little bit towards y, okay, than the parabola one. If the parabola is like this graph will be shifted towards this direction, towards y. Understood? Now I have drawn the two functions. Now my questions comes here. Fx is equal to maximum of x cube. Now maximum of x cube means what? Among those two functions x and x cube, which is the highest? Look at here, guys. Now let me see which one is the highest. If I look at this one and this one, which one is the highest? The x cube value is going down, down, down. It is minimum, right? But this x value is going here. So if you compare these two, which value is maximum? Obviously this value is maximum, right? Again, now let us go to this point. At this point, from here to here, which value is maximum? The upper value is maximum, right? So let me just do one thing. Let me erase this one. I will erase this one. Understood? So here, if we compare these two, again the upper value is maximum. So let us remove this one. Gone away. Maximum of the two. Now let's compare these two. Again, which one is maximum? The straight line is maximum. Let us remove this one. Compare these two. Which one is the maximum? This one is maximum. So remove this one. So this is my curve for fx is equal to maximum of x and x cube. Am I clear? Understood? Now I have a question to every single one of you. In this curve I have drawn, how many sharp corners are there? How many sharp corners are there? Now you will be asking, what is a sharp corner? This one is smooth. Sharp corner means, suppose the function is going like this, suddenly it changes to like this. So this is a sharp corner. A function is going like this, it becomes like this. This is a sharp corner. Okay, so in here, how many sharp corner do you see? A function was going straight like this. Suddenly, it got a jump like that. Sharp corner 1. Again here, sharp corner 2. And again in here, there are sharp corner 3. Right? Understood? So a shortcut is, at the sharp corners, at all those sharp corners, the function will not be differentiable. Understood? So at the sharp corners, the function will not be differentiable. So this point is basically what? It is 1, 1 comma 1. This one is minus 1 comma minus 1. So at minus 1 and 1 and at 0 comma 0. So these 3 points. So what are the points? Minus 1, 0 and 1. So at these 3 points, the function has sharp corners. Yes or no? At these 3 points, the function has sharp corners. And listen, very important thing. So write this one. At all sharp corners, the function fx will not be differentiable. So which option is the correct answer? Which option is it? It is option number D. Understood? I hope this one is a new type of problem you have done. Okay. So guys, that's all for my limits, continuity and differentiability. So let's start a new chapter. Let's start application of derivatives. So what we have is application of derivatives. Now one thing I will try to discuss one at a time. Okay, today I will take the topic of increasing and decreasing function. Okay, so first thing, when I know whether a function is increasing or not, can anybody tell me? Nobody can tell me. I can't hear anyone. How can I hear? It's only I who talk, right? Okay, so how can I know that function fx is increasing? Okay, so what I will do is I will find f dash x. Clear? I will find, simple as that. I am not going through anywhere. I'm just giving a short explanation. How can I say that fx is increasing? If f dash x is greater than 0, f dash x means what? Look at here, guys. I told you that suppose I have a line like this. F dash x is basically dy dx, dy dx, and dy dx means what? Dy dx means what? Slope. And slope means what? Tan theta. So if dy dx is greater than 0, or if this one is positive, positive means what? This one is theta, right? So you see the function is increasing, positive slope, positive slope. So what do we have? Increasing function. The function is going from here to here, increasing. Now if I have a decreasing function, so the angle is what? It's going negative direction. So we have what? Negative slope. So it is from decreasing. Am I clear? So what we have for decreasing, it will be what? Dy dx must be negative, and negative means what? F dash x will be less than 0. Okay, so this is for increasing function. In order to check whether the function is increasing or not, we find f dash x. If it is greater than 0, then we can say that increasing. And if f dash x is less than 0, we have negative slope, we will say that function to be decreasing. Simple as that. Okay, so now let's do one problem of it. We are in JEE Advanced. So the more questions we do, the better it is. So we have to practice again and again. Now we have this question in here. So it's kind of like application of derivatives is also there, and even an odd function logic is also in there. So I hope everybody knows how to check whether a function is even function or not. No, right? Let me do it. Let me just do it, those who don't know. So f of x, if it is equal to f of minus x, then this function is known as even function. Now if f of x is equal to minus of f of minus x, then this function is known as odd function. So this one is odd function, and this one is even function. Clear? And this one we can write it like this. So let us take this one this side. So what do you get? F of x plus f of minus x is equal to 0. This is also odd function. Clear? Understood? So let us start solving this question. So what we have in here, that they have defined a function f 0 to infinity to r given by this thing. There is an integration sign. You see, we are doing application of derivatives and they have given integration. That's what JEE Advanced is all about. Okay, clear? So then what are the options? Monotonically increasing, decreasing. You see increasing and decreasing. When you see increasing and decreasing, what clicks in your head? We have to differentiate. We have to find f dash x, right? Okay, so let's do it. Now last class I told you one formula, and I can guarantee most of you forgot. What was that formula? Even I also forgot. But let's see whether we remember. Together we can remember that thing or not. So what was that? integration of hx gx fx dx is equal to, is it that? No. Differentiation of that thing. D dx of that thing. What was that? It was f of, put hx inside, then differentiation of hx is what? H dash x plus, was it plus? Yes, it was plus. No, it was not plus. How can it be plus? It's not, we are not doing product rule. We are putting the limits of integration. Okay, please remember that thing. It is minus, now put gx in here. F of gx, now g dash x, and that will be it. Okay, so that's how we differentiate an definite integration. Okay, let's do it in here. So fx is this thing, so f dash x will be what? Look at the question, look at that one if you don't understand. Okay, now here the upper limit is what? X. So let us put x everywhere. So what I get? E to the power minus x plus 1 by x, right? This x, don't forget, 1 by x. Now what we have? We have to differentiate this thing. Look at here, h dash x. So differentiation of x is what? Differentiation of x is 1. So we have this one. Clear? Then minus of, now put 1 by x in there. So what do we have? E to the power minus of, so here it will be what? 1 by x plus x. This will become what? X. So it becomes 1 by x. And differentiation of 1 by x is what? Differentiation of 1 by x is what? Come on guys, it is minus 1 by x square. I hope everybody remembers this one. Minus 1 by x square. Okay, clear? So one thing, we made a mistake in here. Can anybody tell me what is the mistake? T becomes 1 by x. Good. 1 by t becomes 1 by x. Opposite is x. 1 by t becomes what? 1 by x, right? Yes or no? Because in place of t I am writing 1 by x. Don't do this mistake. Okay, clear? Please check this one. Now look at here, I am writing 1 by x. I will do it in this step only. If I write 1 by x, this x will go up. So x goes up. X goes up in here. Now since x gone up, this x I can cancel, right? Now let's write it. So what do we have? E to the power minus x plus 1 by x divided by x, right? I'm writing it down, divided by x. Then look at here, minus minus becomes what? Plus. E to the power minus, acha, this one, if I write x plus 1 by x, what's the problem? It's the same thing. Divided by, again there is one x in there, so x. Now these two are the same thing. So can I write this one as 2 e to the power minus x plus 1 by x divided by x, right? Now always remember one thing, e to the power anything is always positive. No matter what you put, e to the power anything will be always positive. Always. Can you think of any value? 2 to the power any value will ever be negative? Nothing. You put 2 to the power 0, it is 1. 2 to the power 2, it is 4. 2 to the power minus 2, it is 1 by 4. If you put negative numbers in here, it will become what? It will become fraction, but it will never be negative. If you put positive numbers, it will also increase, keep on increasing. Now if you put 0, 2 to the power 0, you get 1. So it is never possible to get an exponential to be negative. So this one is always positive, right? Now can you tell me the value of x? What is the value of x? The value of x, I told you what? This part is what? This is known as domain. This 0 to infinity, 0 to 1 infinity is known as domain. Clear? So if it is known as domain, domain is what? Domain gives the values of x, right? Now if it lies within 0 to infinity, what it does signify? It signifies that x is never negative. x is always positive. So if this one is positive, this one is positive, this one is positive, so the whole thing is what? Greater than 0, right? Now if f dash x is greater than 0, so what we can say? That it's an increasing function, right? Achha, where do we see increasing? Where do we see increasing? It is option number A. Understood? Now one thing, it doesn't say the other two options are correct or wrong. So this is basically multiple correct answers. So what I have to do is I have to check option number C and option number D. Okay, so let's do it. So option number C, it says what? That fx plus f1 by x equal to 0. So let's prove that thing. So fx, I know it's this one, right? Let us find f of 1 by x. So f of 1 by x is what? Wherever there is x, put 1 by x. X is there, put 1 by x. I just keep my eyes closed, and wherever I see x, I put 1 by x. 1 by x, it becomes what? 1 by 1 by x, and that is what? X. X. T, nothing will be changed. Only I will change the x into 1 by x. So the inside function will be the same. T plus 1 by t, dt by t. So this is it. That's my f1 by x. Now I will tell you one thing. I hope you guys remember. There was one property of definite integral. What was that property? If I have a to b fx dx is equal to what? Minus of, I will interchange this one, b to a fx dx. Understood? A to b fx dx is equal to minus of b to a fx dx. Can I do the same interchange in here? Let's do it. Yes, I can do it. So minus of 1 by x, x e to the power minus t plus 1 by t dt. Now guys, tell me, have you seen this one before? Have you seen this one before? Please roll back. Please roll back. Yes, I have seen this one before, and that is what? Fx. So write fx there is equal to minus fx. Now drag minus fx the other side. What I get? F of x plus f of 1 by x is equal to 0. Right? Correct. Clear? Now the third option, fourth option. So fourth option is what? F 2 to the power x is an odd function or not, right? So let's do it. Let's do it. Now, look at here, guys. Fx plus f of 1 by x equal to 0, right? Now, can I say, let us putting from here, we will start proving that other one. Putting 2 to the power x in place of x in here. In place of 2 to the power x, I am putting x. So in place of x, I am putting 2 to the power x. So what do we have? F 2 to the power x plus f of 1 by 2 to the power x. Wherever there is x, I am putting 2 to the power x equal to 0. Right? So what we have in here is f 2 to the power x plus f 2 to the power minus x is equal to 0. Yes or no? Now listen very carefully. Suppose I take this one as the function gx. Okay, now let's see. Let us drop this portion. I hope everybody have seen this one before. So if I take this one as gx is equal to f of 2 to the power x. Can anybody tell me what is g of minus x? Nobody can tell me. Only I can tell myself. What is that? G of minus x is what? G of x is this thing. So in place of x, I will put minus x. So it is what? F 2 to the power minus x. That is what, right? Look at here. F 2 to the power x plus f 2 to the power minus x equal to 0. And what was odd function we discussed? The odd function was what? F of x equal to minus of f of minus x, right? Take this one, f of x plus f of minus x equal to 0. This is the condition for odd function, and that is satisfied in here. G of x plus g of minus x equal to 0. That's an odd function. Okay, so now we have our next question, and that is kind of big. Okay, it's so big a question. So when you see a questions like this, the general thing what we do is we skip, right? But we don't skip, we try, because we are at home, we are not at the examination hall. So at home you should try solving these type of questions, so that will drive your fear away. Okay, so please approach these questions and try to solve it, don't skip it. So here, how to solve this question? Look, these questions are like you have to find the small informations from there, and then you will try to break that question. So what small information? Let me write those facts. First thing you see, gx is equal to log of fx. I see this thing, right? The next thing I see, f of x plus 1 is equal to x of fx, right? So from here, what I will do is initial steps. So I'm writing g of x is equal to log of fx. Now somewhere I will try to get f of x plus 1. Now how to get x plus 1? Can I do one thing? Put x plus 1 in place of x. Let us put x plus 1 in place of x. Now if I do that thing, this becomes what? G of x plus 1. G of x plus 1 is equal to log of fx plus 1. Yes, very simple. Now I have seen fx plus 1 somewhere. It's here. So I can write x into fx. So that becomes what? G of x plus 1 is equal to log of x into fx. Right? Now what will I do this one? Let us break logarithm. What can I do? So it is g of x plus 1 is equal to log x plus log of fx. I can write this thing, right? Achha, log of fx is what? Here is so many things we have to find. Let us roll back. Log of fx is gx. Let's write that thing. So g of x plus 1 is equal to log of x plus gx. You see, you will get this kind of form in there. Take gx this side. G of x plus 1 minus gx is equal to log of x. Yes, now you see, you have a hint in here. There is double dash in here. Double dash means what? Double differentiate, right? Let us do that thing. One by one, we'll go. Let us do first derivative. Then I will do double derivative. We cannot do in the same step. So if I do first derivative, f dash x plus 1 minus g dash x. Differentiation of log x is what? 1 by x. So let's write that thing. Now if I do double derivative of this thing, so we have, Achha, here we write one first derivative, so double derivative minus g double dash x is equal to, achha, differentiation of 1 by x is, I told you before, it's minus 1 by x squared. Clear? Now you see this one and you see this one. It's kind of like looks same, but there is a problem. What problem is there? You see it is n plus half, right? So there is one manipulation we have to do. What type of manipulation? I have to get this one in terms of something plus half. It is x plus 1, right? But x has to be there. So what I will write? So I will write putting x minus half in place of x. Putting x minus half in place of x. Let's see what happens. Now if I put x minus half in here, what happens? Minus half plus 1 becomes what? Plus half. So g double dash, what we have? X plus half minus g double dash. Here in place of x I am writing x minus half. So what I get? X minus half is equal to, we have to replace x in here too. So this becomes minus of 1 divided by x minus half whole square. Okay, now let us write in term proper form. So if I do the LCM, it becomes what? 2x minus 1, and this 2 square will go up. So it becomes what? Minus of 2 square divided by 2x minus 1 whole square. This is what we have. Am I clear? Acha, now what we do? Now what we do is, in place of x, now keep on writing some values. When x equal to 1, let us see. When x equal to 1, what happens? If x equal to 1, 1 plus half is what? 3 by 2. G double dash 3 by 2 minus x equal to 1. 1 minus half is what? Half. G double dash half is equal to minus of 2 square. What is 2 square? 4. Forget it. 4. 2 into 1 minus 1. How much is that? It's 1 only. Why am I thinking so much? Okay, clear? Now let us put x equal to 2. So if I put x equal to 2, what will happen? Do it like that. G double dash 2 plus half is how much? 5 by 2 minus G double dash. Now we'll do it fast. 2 minus 1 by 2 is 3 by 2. Now I think after this you will get the point. Now if you put 2 in there, how much you get? So 4 minus 1, that is 3 square. So minus 4 divided by 3 square. Okay, now the next one I don't have to check, I will just write it. G double dash x equal to 3. It will be what? G double dash 7 by 2. You see odd numbers, 3, 5, 7 minus G double dash, this one will come there, 5 by 2 is equal to minus 4 by, the next one will be what? It will be 5 square. You put there 3, that is 2 into, put here 2 into 3 is 6. 6 minus 1 is 5. 5 square. You get this one as 5 square. Understood? Now at the end, what I put? It is n in here, right? So let us put n in there. So dot 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 dot. Now x equal to n, we have what? X equal to n, we have what? G double dash. Listen carefully. I am putting one thing. Let us see. This 3 by 2, I can write it as what? 1 plus 1 by 2. This 5 by 2, I can write it as 2 plus 1 by 2. This 7 by 2, I can write it what? 3 plus 1 by 2. So we have in here n plus, I am putting 3, x as 3, 3 plus 1 by 2. So n plus 1 by 2 minus G double dash n minus 1 by 2. X plus 1 by 2, x minus 1 by 2 is equal to minus, it will become what? Come on guys, tell me fast. It will be 4 divided by, look at here, in place of x, if I put n, so what I get? Minus 4. Let me write it somewhere else. Let me write in here. Okay, minus 4 divided by 2n minus 1 whole square. Am I clear? Okay, so that's what we have. So now what I will do is, I will add all of them. Pause. Niche test. Now, so start from where we left off. So now I will add all of them. Look at here guys. G double dash 3 by 2, G double dash 3 by 2, plus sign minus sign, cancel. 5 by 2, cancel. All of them will cancel. 7 by 2 will cancel with 7 by 2. So what will remain is, this n plus half will remain and this minus half will remain. So what we have is G double dash n plus 1 by 2 minus of G double dash half, and that will be equal to what? That will be equal to, look, I can take minus 4 common from everywhere. I can take minus 4 common. So what do we have? Minus 4 taken common. So here we have 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot 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 1 by 2n minus 1 whole square. Which option is it? This one. Minus 4 is there. 1 by 1 square, 1 by 3 square, 1 by 5 square, 2n minus 1 whole square. This option is the correct option. Okay, so that's it for today. So we have solved some of the questions and we have done application of derivatives. So we'll see you back tomorrow, and please, if you have any doubts, drop it down in the comment box. Okay, and please like and share. So that's it for today.